have physics, principle of moment. Now, first of all, you have to understand what moment is all about. Moment is the turning effect of a force about a point or about an axis. That is what we call moment. For example, now, if I open a door, if I put my hand is the force, and when I touch the handle like this, pull it, the door turns, rotates about its axis, or what we call hinges. So that is what we call moment, example of moment. Or when you also open up a bottle top, like your mineral top, when you put here, you want to open it like this, pull it like this, the turning effect of that force about that point is what we call moment. Now we want to look at, and also we have what we call moment of a force. Moment of a force now is the product of the force and the perpendicular distance along its line of what action. That is what we call moment of a force. There is a difference between moment of a force and the moment. Moment itself is the turning effect of the force about a point or an axis, while the moment of a force is the product of from the door to the hinges is called what? The perpendicular distance along its line of what action. So that is what we call moment of a force. We want to look at the principle of moment. This principle states that if a body is in equilibrium, we know what is equilibrium. When a body is not either at rest or move with a uniform speed. When we say a body can be at rest and be in equilibrium. A body can be moving and be in equilibrium. When it is rotating like a fan that is not rotating is in equilibrium. When it rotates with a constant angular speed is also in equilibrium. So now we say that a body is, this law state that what, or principle state that if a body is in equilibrium, then the sum of clockwise moment about any point on the body is equals to the sum of anti-clockwise moment about the same point. That is what this principle states. That when a body is in equilibrium, the sum of clockwise moment about any point on the body is equals to the sum of anti-clockwise moment. Now let me demonstrate it now. Okay, this could be a meter rule or a, let me say, a seesaw resting on a knife edge. This is called pivot. This is called pivot. This is where this knife edge or rod is balanced. So if we have several forces now, like if I have force, let me say here are several forces. This is F1, F2. Then distance from this F1 to here is called D2. While distance from here to here is called D1. Then if I have another force here now, F3, the distance from here to here is called D3. And the distance, another one, F4 here, the distance is D4. This is force 4. So according to the principle of this moment, this side is called clockwise moment. This side, this is the hand of a clock, move this way, clockwise moment. And this is called anti-clockwise moment. This is anti-clockwise moment. So according to the principle now, this is a clockwise moment about point C is now equals to F2 times the perpendicular distance is D2 for this point now, plus F1, or you can say F1 first. You can say F1 times D1 plus F2 times D2. So this is called what now? Clockwise moment. Then this is clockwise moment. Then anti-clockwise moment. Let me use here now as anti-clockwise moment. Anti-clockwise moment about the same point, about point what? C. This is 10 points according to the principle. The principle states that the sum of what? Clockwise moment about any point is the same thing as, or is equal to the anti-clockwise about the same point. So the clockwise, anti-clockwise moment about this point now will be that anti-clockwise moment about point C now will be F3 times D3 plus F4 times D4. So now F1 times D1, F2 times the particular distance D2, F for clockwise moment, anti-clockwise moment, F3 times D3, and F4 times D4 for anti-clockwise moment. So according to this principle, clockwise moment is equals to anti-clockwise moment. Clockwise moment equals to anti-clockwise moment. That is F1 D1 plus F2 D2 equals to F3 D3 plus F4 D4. So we use this to solve. If D is unknown, you can use this. If D1 is unknown, we can use this to find this equation to find it. If D2 is unknown, we can use this formula to find it. Now remember that we can also say that upward forces equals to downward forces. Upward forces is equals to, for a body to be in equilibrium, upward forces also equals to downward forces. Likewise, we say what some of the moments, some of the clockwise moments equals to some of the anti-clockwise moment. A uniform half meter metal rod AB is balanced horizontally on a knife edge placed 20 cm from A and with the mass of 35 grams. What is the mass of the rod? Okay, let us draw the diagram before we can calculate and say solution. Let this be. Now let half meter, half what? Half is what? Since it is meter and half of it is what? Half will be what? The distance is in centimeter, so half of it will be 50 cm. Total of it, that is full meter rod, will be what? 100 centimeter to make 1 meter. So they said that this is what now? Half of it is 50. So it was pivoted. If here is A, here is B, it was pivoted 20 cm from A. So from here to here, we can say here it is where it is pivoted, 20 cm. Then, and a mass of what now? And a mass of 35 grams hangs this point. Then the next question now say, what is the mass of this rod? This is rod now, meter rod. The mass of this, according to center of gravity, you know, when you talk about center of gravity of a rod, it will be at the midpoint. So where the center, the mass of this rod will lie is at the center of gravity. So center of this will be, let me call here now 25 cm. So this will be where the mass of the rod will lie, at the half of the rod. That is called midpoint. We call it midpoint. So this is where, so what is the distance from here to here now? The distance from here to here, if from here to here is 20, and from here to here is what now? 25. So here will be what? 5 cm. Here we go 5 cm. Because we have subtracted 20. And since this mass is in gram, we don't need to convert anything. If this is in kilogram, we would have converted what? Cm to meter. But since this is gram, this is cm, we continue. So you know, this is what now? Clockwise moment. Clockwise moment. This is called anti-clockwise moment. So anti-clockwise moment. So using clockwise moment equals to anti-clockwise moment, we can now find the value of this m. Clockwise moment equals to anti-clockwise moment, about the same point. So our clockwise moment is m times the distance is what? 5 equals to our anti-clockwise moment is this mass times the distance from this pivot. We are talking about this pivot or this knife edge is always the point. So it will be what now? 35 times the distance is 20. So when you multiply now, m equals to 35 times 20 divided by what? 5. 5 divided this is 7. So you now have m equals to 7 times 20, which is 1 m equals to 140 gram. So the mass of the what? The rod is 140. So you have seen how we apply that word principle of moment.